morning, everyone. We are Silvia from Politecnico di Milano, Italy, and Nicola from SPECIFICATION, France. And with this presentation, we are going to talk about BIM-related information technologies that, according to literature, but also examples from the industry talks to the experts, can be used to manage information requirements in a data-driven design process. Just a few information about our backgrounds. We are both PhD candidates dealing with BIM implementation, even if in different topics, and working on buildings and briefing process. Nicola is working with, is dealing with system engineering implementation construction projects. And this paper has been developed during a collaboration, and it represents a contact point between our researches. During this presentation, we are going to describe the framework within which this paper has been developed, introducing some concepts related to the briefing process and implementation of requirements engineering in construction projects. Then we are going also to introduce the concept of digital brief and information technologies that can be implemented for managing that. And before stating some limitations of the presented paper and also proposing some conclusions and questions for future works, we're going to briefly introduce some ongoing case studies we're working on related to that topic. First of all, the focus is on the client-designer interface. In fact, in the ongoing digital transition, the client is asked to act as a driver for innovation and major changes in both processes and technologies in order to manage the entire process and to influence effectively all of the other parties. And it is online digital transition also the way in which requirements are set and managed should be reconfigured according to digital innovation. And in fact, digitalized clients' requirements should become the starting point of an effectively data-driven design process. First of all, in order to do that, the clients should be able to articulate computable requirements and also to have a clear idea of what he needs to know from the building information model at each stage of the decision-making process. That's essential, for example, in order to evaluate if design proposals are compliant with design requirements stated by the clients and other stakeholders, and to be able to manage that gap between as briefed and as required and act upon that knowledge. BIM-related technologies already exist to support this bidirectional communication and to support also a better data consistency between during the iterative briefing and design process, and we're going to give a sort of overview about that. The briefing process is the client's project management process, during which is able to manage the dialogue with the supply side in each project phases. Basically, it's a collaborative process of information management indeed, and during this process, requirements stated by the clients are analyzed, evaluated, and managed in sets of requirements. This is a dynamic and iterative comparison between problem formulation and problem solving, characterized by a gradual deepening over the project stages and the heterogeneity of the stakeholders involved. The result of this process is the brief, which is a working document containing sets of requirements coming from different stakeholders, and they have to be translated into design proposals. Usually a brief is a balance between computable object-oriented prescriptions, which are within the scope of this paper, and text-based performance requirements. As we said, there is now, with the ongoing digital transition, also the need to digitalize the brief as well and to structure it as a database, as well as the design proposal developed in a building information model. That's useful to guarantee the bidirectional link between as briefed and as designed, and also to get automatic reporting, real-time compliance checking, supporting the clients to effectively keep under control the design process and trace also requirements changes back, and to have a clear idea of what's going on. The concept of digital brief is introduced in BIM-related standards. For example, the British standards for briefing in construction for both buildings and infrastructures say that, suggest that if you want to check the design team response to the needs of clients and end users, you should evaluate them with a digital brief against which to evaluate proposals and automatically validate that. Different tools, as we said, have been already developed to manage a digital brief. For example, British standards don't say what is a digital brief and how to create that. So we started with an overview of possible technologies and researches that have been developed so far related to that. We're going to talk about briefing software, data exchangers, and to briefly introduce some researches that has been done related to the possibility to extend the JC specification to manage design requirements. And they were also trying to analyze different approaches coming from other domains, such as requirements engineering. So before describing technologies, Nicola is going to give some few concepts about approaches from other domains.
Thank you, Silvia. So yes, dealing with requirements and briefing, we looked at also at other domains and how in other domains requirements were managed and modeled. And system engineering is particularly used, for example, in the automotive or aerospace or aeronautics industry to model, manage, and even structure requirements. So basically what is system engineering? It's a methodological corpus used to design, build, and manage complex socio-technical man-made systems within schedule, cost, and expected performances. Actually, system engineering have been used only few in the construction industry, and mostly in other domains, as I explained. And there are a few concepts that help us to structure requirements. For instance, the V-cycle representation allows to define a requirement from the system level to the subsystem level and then sub-subsystem level, etc. And then the system gets integrated into other branch where requirements are verified and validated. Another way to structure requirements is the systems architecture, where requirements are defined as operational requirements. It's explains what is the mission of the system, why the system has to be built. Then functional requirements, which explain what the system actually does. And finally, structural requirements, which explain how the system is composed. So basically, these two concepts help to structure the requirements. Basically, requirement engineering is one part of system engineering, and it is a systematic approach consisting in rules and methods to specify, model, and manage requirements through the entire system lifecycle. So there are actually two types of engineering tools dealing with requirements. One is requirement modeling, which helps to elucidate, describe, analyze, specify, and validate requirements. They are basically based on SYSML, which is Systems Modeling Language, and I will get more into the detail of what is SYSML and how to use it later. And also requirement management tools to store, change, and trace requirements in the system, and it's tools like those and Rectify, for example. Yes, so in the next slide, Sylvia will show and explain different tools to make the link between requirements and the briefing, and I will get more into the detail of the system tool.
So as we said, we have started analyzing what are the possibilities to create a digital brief. Actually, different commercial solutions already exist and the research has been done. In this case, we have decided to consider the different tools, for example, with their capacity to modeling requirements, how they are linked to the blended information model, and if they are not, for example, IFC compliant and they support an open standard approach. Briefing software, for example, are object-based requirements management systems. They are used to capture, organize, manage, and maintain functional requirements, mostly related to the rooms. So we're going to manage requirements in room templates, room data sheets, and the equipment and furniture sheets. And they are used to connect the S-brief requirements to the design solution, and so to validate the deviation by a bidirectional link with the building information model. Usually, they are used by the client for supporting the planning process of complex buildings, but with the link with the building information model, also designers have started to implement this kind of tool in their workflow in order to use clients' requirements as inputs for data-driven processes and to be sure about the compliance between proposals and requirements. This kind of tool can be synchronized bidirectionally with the building information model by means of an IFC-based import-export process or with the use of plugins that exist for some of the mainly modern platforms. Another kind of tools that is recently more and more used in the industry are data exchangers. Data exchangers are cloud-based and visual scripting systems that are used to link a digital brief developed in a data spreadsheet, for example, and the building information model. In this case, the client has the possibility to manage the design process with a tool that is familiar with, like a data spreadsheet, and the design team is able to take requirements and that brief data coming from the digital brief and to feed parameters in the building information model directly. The bidirectional link is made by a synchronization between the tools, but in this case, that exchange is not standard-based. So there are plugins available, but we are not working in a standard-based, IFC-based approach. According to the management of requirements within a BIM environment, of course, there are some researches. For example, Kiviniemi was one of the first, more than 10 years ago, that introduced this topic, developing a requirements on the specification, and then other projects implemented, for example, the property set product requirements or the IFC space program in the IFC 2x3 specification. And recently, the BP program introduced some exchange requirements and the process map for managing the briefing requirements. And now the IFC4 contains some room datasheet property set, which are named requirements, for example, the space occupancy requirements. And Marchand just a couple of years ago proposed to integrate in a single data repository requirements specified in an IFC-based specification, proposing an extension with the IFC that requires and related subclasses.
So SYSML-based tool, so SYSML standing for Systems Modeling Language. It's actually a meta model to model a system. It is composed basically of 9 diagrams. So it's diagrams with links and blocks and stuff like that. And one of these diagrams is the requirement diagram. And the idea is that the requirement diagram can be linked with other types of diagrams, like blocks diagram or activity diagrams, explaining how the system is composed and what is the behavior of the system. And so, of course, this meta model and this language is compliant with system engineering methodologies, and it's used extensively in system engineering. And according to literature review, it seems possible to link SYSML-based tool with BIM models. But we haven't been able to test it yet, but apparently it's possible. And so the idea is to model the requirements with SYSML. So we have ongoing case studies to test those different tools to model the requirements and to link it with the model. It's a briefing software data exchanger tested by Sylvia in Milano. And we are now testing a SYSML-based tool in France with my university at JC3 and also with my company Aegis, and I will show an example later. And so we test those tools in order to see how they can manage requirements, how they can keep requirements updated, and how to use those requirements as design input, and how those tools help to validate design proposals against requirements. So we have actually done one case study in France on the scarboroughs of the Greater Paris Project 2016. So actually only little subsystem of the bigger system, which is mutual networks, to model the requirements. There was more than 100 requirements to model. And so we used SYSML to model the requirements and then to link those requirements with blocks where we also model the system with blocks. And so then we can have like an allocation matrix when you have on one side the requirements, on the other side the different objects of the system, and then you can evaluate when changing one object what are the impact of the requirements, and the other way, when you change the requirements, you can see what are the impacts on the blocks and the object input in the system.
Okay, so let's go to summarize the technologies and methodologies that we have analyzed. We have taken into account in this brief overview, and we are considering the necessity, as we said at the beginning, to link a brief digitalized as a database, as well as the building information model, which represents the design solution, and to keep this bidirectional link alive during the design process. And for that, we have taken into account BIM-related technologies, and we have introduced the possibilities coming from other industries. This kind of link, as we said, it can be managed by means of plugin, by means of IFC-based processes, with data exchangers and visual scripting system, and some researchers are hypothesized the possibility to extend the IFC specification to manage requirements, integrating them within the data repository of the building information model. So we have the possibility to synchronize requirements in model-driven requirements management tool and integrate them within the building information model. Basically, we have seen that briefing software that are commercially available can be linked to the building information model by means of an IFC-based process and also with the plugins that facilitate the interoperability between them, while data spreadsheet can't be implemented, at least so far, without some specific setting from the user, with an IFC-based approach. On the other hand, they are more and more used in the industry nowadays, and some of the main design and engineering firms are supporting this kind of tool for reducing interoperability issues. That's a way to solve some problems nowadays at present, but on the long term, maybe it's not the right solution because we are developing a data flow that is not standard compliant. We have seen some researchers, as we said, that developed IFC-based interface for that, based on the typical specification and proposing extension. And we have started to analyze this SYSML-based tool. And according to literature review, the link can be managed by a data spreadsheet, but there are to do some work more in order to understand if we are going to miss some information in this workflow, in this data flow, because we are reducing the level of information that we have related to the requirements, and maybe it is an export-import phase. And so we need to check more about the possibility to link the two domains. Just to conclude, some highlights and possible questions for future works.
So the future work can be directed on BIM-related technologies, and how is it possible to detail more the comparison between data flows based on standards and natural formats. But also there are some requirements which are more difficult than others to model and to computerize, and so that's another way of research to see what are the requirements we can easily model and computerize and control that, and so how to deal with those requirements which are not very easy to model. Another thing is about the implementation of requirement engineering more generally in the construction industry, because first, how to link the SYSML requirements diagram, for example, more generally SYSML, with the BIM model through IFC, for example. And another thing is, one problem we had when using SYSML in, for example, the Retro project is that it is very difficult to model space information with SYSML. And so maybe one possibility would be to define a new what we call DSML, which is domain-specific modeling language, specifically for the construction domain, maybe integrating space information like geometry or topology information, for example. And so another way to do future work is to improve the briefing process. We have presented in this paper the comparison between as briefed and as designed, but maybe it is also necessary to study as designed versus as built, and also as designed versus as implemented. Another question we ask is, what are the information required at each stage of the decision-making process, and so what are the types of information and the level of information required. And also, maybe there are new roles and new information management processes to develop with the client organizations to manage and model requirements. Thank you for your attention.
Thank you for the presentation.